Alright, today I wanted to make a quick video about exponents and logarithms. So the first thing that we're going to do is we're going to look at 2 squared equals 4. Now what in the world does 2 squared equals 4 mean? Well, think about it like this. Right now, your teacher is about a little taller, but about 6 feet tall. Alright? Now think, if I grew twice as tall every year, all right, so in 2020, I am 6 feet tall. If I grew twice as tall, how tall would I be in 2021? Every year. Well, you guessed it, I would be 12 feet tall next year. And the year after that, in 2022, I would be 24 feet tall. Okay? So this year I'd be 6 feet. Next year I'd be 12 feet. And 2 years from now I would be 24 feet tall if I doubled in size every year. So think about it this way. In 2 years, I would be 4 times as tall as I am when I started, because 4 times 6 is obviously 24. So let's go back to what this means. 2 squared means the rate at which I am growing is 2. I'm doubling each year. The amount of time is your exponent, or your index. So the amount of time is 2 years. And 4 tells me my result. So I double in size every year. It takes me 2 years. My result is 4 times as big as when I started. All right, well, let's think about it. So what is 2 to the first power? Well, the rate, once again, I'm doubling every year. Right? The time is 1 year. So after 1 year, how much taller am I than when I first started? I'm 2 times as tall. Okay, let's keep going. What if I told you, what is 2 to the 0 power? Well, let's think about it. The rate is I'm doubling. The time is 0, which means I haven't done anything yet. So how tall am I when I first started? Well, I'm the exact same size that when I first started. I haven't grown at all. I haven't doubled in size. I haven't quadrupled in size. I'm the exact same size that I am now. So that's my result. I'm the exact same size I am when I started. Okay? Let's go a step further. What does 2 to the negative 1 mean? Well, think about it. Rate is 2. Time is a year in the past. So if I'm 6 feet tall now, how tall was I last year? How tall was I in 2019? 3 feet. I was half the size that I am now. So I'm half the size that I am now. Now here's what logarithms do. Logarithms take all of this information and turn it on its head. So whereas 2, for example, 2 to the third equals 8, right? Which, once again, this is rate, time, result. What logarithms do is they rethink how we're stating these exponents. In other words, they're still saying, they still start off with the rate. They're saying at a rate of 2 times a year, how long will it take me to get to 8? In other words, if I'm doubling each year, how long will it take me to get 8 times as big? Well, that is 3 years. You see, logarithms just rearrange the exponent. At a rate of 2, how long does it take me to get to my result? So notice here in exponents, the focus is on the result. In logarithms, the focus is on the time. All right, I'm going to say that again. On exponents, the focus is on the result. Logarithms, the focus is on the time. Now, a way you can think about it, I'm going to go back with 2 cubed equals 8, is you can think of logarithms by doing this little kind of G shape. You think about log as a G. So if I wanted to turn this into a logarithm, I start here, hit 2, hit 8, and hit 3. Why? Because this means log base 2 of 8 equals 3. You see how I went in order? Hit 2 first, then hit 8, then hit 3. I replaced it like that. And it works the other way too. 2 to the third power equals 8. Okay? And that's how you can switch logarithms around. And that's, for the most part, the main idea. Now, let's do a couple of problems and see if we can work through them. All right. What is log base 3 of 9? What's log base 3 of 9? Well, let's think about it. The rate is 3. The result is 9. How many times will I have to triple to get to 9? The answer is twice. Why? Because 3 to the second power is 9. All right. What about log base 4 of 64? Well, one thing that you can do, a way you can do this is, let's say you don't know that 4 cubed is 64, which it is. You could take 64, all right, in your calculator, and then divide by 4, which gives me 16. And you can try 16 divided by 4, or rather, you can think about it like this. 64 breaks down into 16 and 4, which breaks down to 4 and 4. Right? So how many 4s do I have? 3. All right, let's do another example of that. Log base 3, 81. Well, you look at 81, break that into 9 and 9, break that into 3, 3, 3, and 3. How many 3s do I have? 4. So that's another way of thinking about it. Okay, here's kind of a curveball. What's log base 1 Actually, let's make this base 5 of 1. Well, if I'm quintupling, or I'm multiplying by 5 each time, and my result was 1, in other words, my result was the exact same amount as when I started, I haven't done anything. So that's the answer, 0. And what about log base 5 of 1 over 25? Well, let's think about it. If I'm 1/25th the size of when I first started, that means I will have had to go back in the past twice. So if I've gone into the past twice, the answer must be -2. And that's it.